So for this problem, we have a car that's coasting along a hill. It goes down the hill, and at the bottom it's going faster. It makes most sense to call the bottom of the hill y equals 0, so we make sure we put that on our diagram. In this case, we know the initial velocity. It's going to be different for you, but it's something. Maybe let's say 10 meters per second. And at the bottom of the hill, the problem says that it has increased its speed by 8 meters per second. So that just means at the bottom of the hill, the final velocity is going to be the initial velocity plus 8 meters per second. So if it was 10, it's going to be 18. That's not too hard to figure out. We know the final height of the hill is 0 because of the way we define the problem, and we are looking for the initial height of the hill. We know the work is 0 because the problem told us that we can assume energy is conserved. We do not know the mass of the car. So what we're going to do is apply the work energy theorem, which says that the mechanical energy of the car at the end of the problem, that's at the bottom of the hill, equals the mechanical energy at the beginning of the problem plus the work. It helps to write out what this means. That means that 1/2 mv final squared plus mgh final equals 1/2 mv initial squared plus mgh initial plus work. And then looking at your variable list, you can see that this is 0, and you know the final height is also 0, which removes that term from the equation. So basically, from this equation that you have that's left, you are going to solve for the initial height right here. Okay? A couple things to make your life easy a little bit, or easier. One is the fact that every single term that's left here has an m in it, so those will cancel. And then I would multiply through by 2. So when you do those two things, the m's cancel, multiply by 2, you're going to get v final squared equals v initial squared plus 2 gh initial. And of course, you're solving for h initial, so you can subtract v0 from both sides, and then divide both sides by 2g to get an algebraic expression. And then at the end, make sure you plug in your numbers to get a numerical expression.